My original interest in geothermal energy came before I knew I wanted to be a geologist. It was a school trip to Iceland when I was 16, and we visited one of the power plants. I was just fascinated by how much heat and how much power you could get from the Earth's renewable resources. I'm David Walls. I'm a PhD researcher at University of Strathclyde. I'm almost done my thesis. Once I've finished this, I'll be moving on to TownRock Energy to be a geothermal geologist. There's been huge strides across the UK at decarbonising the grid and the electricity, but one of the main challenges left is still to decarbonise the heat. Geothermal is actually one of the only resources which can be used as renewable heating in order to help make a difference.
In 2 minutes, you are 1,200 feet below the fertile Scottish countryside. When the men are well clear of the face, the shot is fired and goes another piece of coal.
The reason there's a geothermal resource in old mines is because all of the material that was extracted from these now leaves voids underground. We can then access these voids, and with the water that's held in them, we can achieve medium temperatures but high flow rates.
Flow rates and water temperature determine how much heat can be delivered to a building.
Topics like geothermal are really important for our future because they apply directly to a low emission and low carbon future. I'm Neil Burnside. I'm a Chancellor's Research Fellow at the University of Strathclyde. I teach hydrogeology and I am David's supervisor.
One of the main parts of my thesis is that I've created an interactive map to show where I think the mines across Scotland are best placed for Minewater geothermal. I realised that the resource for mine water is not just underground, and there are places where it pours out of the surface. I got an old database from SEPA, early 2000s, and I plotted all of the points that they said on a map. This meant that I could spend a couple days a week just cycling across the central belt of Scotland, visiting discharge, and then sampling it for water chemistry. As a child, I just loved being outside all the time. Our family holidays were often cycling and camping across some of the Scottish Isles or in Netherlands or France.
My love for the outdoors has continued, giving me a deeper understanding of the risks associated with climate change.
The thing with climate change is that we can already see the effects happening, and this means that the job that I do actually gives me so much purpose because I know that I'm making a difference.
The core aim of my project is to use my work to put boreholes in the ground. To facilitate that, I have made my interactive map open access. The close proximity of mines to towns across Scotland makes Minewater geothermal a particularly attractive and beneficial source of energy for houses and businesses. When visiting a mine discharge, I measure flow rates and chemistry. This helps me predict how water affects the machinery. My research found large heat resources from mines near and beneath Scottish towns.
So this borehole is actually part of an observation scheme that we've got going on as part of my PhD. The great thing with geothermal is that most of the infrastructure is underground, which means that there's not actually a huge footprint at the surface of the site. A lot of developers across the Central Belt will need to do ground investigation to explore their sites. Do you think it's been worthwhile looking for the potential for Minewater geothermal at the same time?
Absolutely, yeah. To see what the potential was, to try and make the whole housing development as sustainable as possible.
This map here shows a lot of different black dots which indicate where there were pits, and there were many pits over the years.
My name's Dougie Blackie. I've stayed in Dollar all my life. I started in the mining industry in 1966 until it finished in 2002. There was a lot of water in Dollar Mine, which was all pumped to a main pump house in the pit bottom, where they had 3 turbine pumps that pumped to the surface. They pumped 650 gallons per minute to the surface. Well, when they were abandoned, the top 40 or 50 metres was filled in with debris of any kind, and what was left underground was just left to flood.
It's as near a true likeness of what the mine was.
So given that we know there are void spaces underground here, and we know that these void spaces are now flooded with water, what do you think about the concept of using that water as a source of low carbon heating?
I'm all for it personally, and it's there and it's doing nothing, you know, and it's just going to waste at the moment, and I think that's a very positive situation to be in.
I think the concept for using mines for geothermal is a great idea if it's viable and profitable.
It has been estimated that we can meet 1/3 of our domestic heating demand per year purely from mine water.
We need more people to know about geothermal. It's so difficult to know what the resource is when it's tucked away underneath the surface. What we have though is an opportunity, and that's an opportunity to transfer some of the jobs from the redundancies in oil and gas, but also actually combat fuel poverty across much of Scotland.